Welcome to the third video in the FISAB training series on European fire safety regulations for sandwich panel products. In this video, we will talk about the behavior of sandwich wall and roof panels when exposed to fire. When one face of a sandwich panel assembly is exposed to fire, the following behavior can be expected. Initially, the panel bows towards the fire, with the ends of the panel moving due to the expansion of the fire-exposed face. When delamination occurs on the fire-exposed face, the assembly loses its flexural strength, and unless both faces are restrained at the ends, the panel can collapse. The fastenings for the ends of the fire-exposed face must support the dead load of the face, while the fastenings for the ends of the unexposed face must support the combined dead load of the face and the core for the entire fire resistance period. Combined fixations, such as through fixings for both faces, are also possible. The figure here illustrates the different stages of sandwich panel behavior from the early stages to the end of the fire. Delamination in metal face sandwich panels refers to the separation of the outer metal facings from the core material. This phenomenon occurs when the adhesive bond between the facings and the core fails, leading to a loss of composite action and structural integrity. When delamination occurs, the facings can no longer effectively carry tensile and compressive forces, and the core cannot adequately resist shear forces. This compromises the panel's load-bearing capacity and overall performance. When one face of a sandwich panel ceiling is exposed to fire, the following behavior may be expected. Delamination of the fire-exposed face will occur after a couple of minutes in a fire. After delamination, as depicted in this figure, the flexural strength of the assembly is lost, and unless both faces are restrained at the ends, the panels can collapse. The fastenings for the ends of the panels need to support the dead load of the whole panel for the entire fire resistance period. The behavior slightly differs depending on the direction of the fire, from above or below. In both cases, the structure acts as a catenary construction. Any possible external load of any HVAC systems, etc. above the ceiling must be considered in fire design. Calculations of panel fastening capacity shall be made for both metal sheets, assuming that both can carry the full dead load of the panel in unexposed condition, and the load of the steel sheet only in exposed condition. However, fire can significantly weaken the core material and adhesive bonds, increasing the risk of collapse and compromising the panel's ability to support these loads. Furthermore, roof panels act as a major pathway for heat transmission into the building. As the core degrades during a fire, heat transfer to the interior accelerates, potentially igniting nearby materials. Fire can also create breaches in the panel, allowing smoke to enter the building and pose a greater threat to occupants. The fixing system shall have the sufficient load-bearing capacity to support the wall panel, which means the weight of panel and catenary forces, for the entire fire resistance period. For vertical mounting orientation of the panel, this figure shows the equations together with illustrations to calculate the catenary forces, where Q is the air pressure and J is the weight of the panel. Similarly, for the horizontal mounting orientation of the panel, the fixing system shall have the sufficient load-bearing capacity to support the ceiling. That includes the weight of the panel and catenary forces for the entire fire resistance period. The following equations for the catenary forces are taken from SFS EN 15254-5. However, those equations are being revised and are not final yet. Here is an example of calculating the catenary forces for a sandwich panel ceiling which is exposed to fire. D here refers to the displacement and it is calculated using this equation. To calculate the catenary force H, the following equation is used. L is the length of the panel, alpha is the coefficient of linear thermal expansion, T is the temperature rise, and W is the distributed load. To calculate the weight per unit length, we first find the volume of one facing and multiply it with steel density and divide it by panel's length, and finally we find the catenary force H using the highlighted equation on the right. So in a fire situation, the fasteners should be strong enough to withstand the weight of the steel sheets. That way, a total collapse of the panel is prevented. This is the end of this training video. In the next one, we will dive into some of the engineering considerations and solutions that enhance the fire safety of sandwich panels in building design. Thank you and see you in the next video.